Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's lesson, we will talk about AC and rectification past paper question from Cambridge A2 Physics. This is our third video on this topic. In this video, I will explain you how to calculate mean value and how to calculate RMS value. At the end of the video, we will also talk about energy dissipated in a circuit. Here is our first question, and for this question, current against time is given to us. We need to be just a little careful because the time is on x-axis and time is in milliseconds. It is not in seconds. What we need to find, simply we need to find the frequency of the current. So this is quite straightforward one. Simply we need to find time period, and 1 over time period is equal to frequency. So first of all, let's try to find the time period. As you can see here, I already labeled this time. So time here is 2.5 and time here is equal to 17.5 seconds. So we can calculate the time for one complete cycle. Simply means that time taken will be equal to time period. Simply we need to just subtract these two numbers, or simply you can say these two values. So here is our final answer. So this is how we have calculated the time period. So this is time period and this is equal to 15 milliseconds, and frequency is equal to 1 over t. So this is our final answer. So this is frequency. Here is our part B. For part B, simply we need to calculate the mean current. It simply means that we need to take the positive value of current and also we need to take the negative value of current. We just need to add these two values and divide by 2. That will be mean current. So how we can calculate? So here you can see here I have already done for you. So this is positive value of peak current and this is negative value of peak current. We just added these two and divided by 2 because we need to calculate the mean value. And our final answer is 0. And this is true for any sine curve. For part C, simply we need to calculate RMS value. Means IRMS we need to calculate, and IRMS simply we can say is equal to IRMS. This is equal to peak value of current divided by root of 2. In this case, peak value we already have. As you can see here, this is the peak value. If you are not clear, you can also find from here. This is equal to 0.75 and we just need to divide by root of 2 and our final answer will be 0.53. So this is our final answer. For this part, we need to calculate the energy dissipated by the resistor, and the time is given to us. Time is from t is equal to 0 to t is equal to 30 milliseconds, and resistance is also given to us and current is also given. But for current, actually we have 3 different values. Those are given to us. The first value is mean value and the mean value is equal to 0. The second one is the peak value and the third one is the RMS value. So which value of current we have to use to calculate energy dissipated by the resistor? First of all, mean value is given. This is I is equal to 0 and the peak value is only at certain period of time. This value is not constant, so we cannot use that value. But for IRMS, we need to understand IRMS actually is equal to IDC, direct current, for example, for a constant value. So if you need to calculate the energy dissipated, we simply need to use IRMS. We should not use I peak. We cannot use I mean. And so let's try to calculate energy dissipated now. So energy simply is equal to I square RT. So we have time, we have resistance, and this value has to be IRMS. Now we just need to plug in values. The IRMS we have calculated, that was equal to 0.53. This value we have just calculated in part C, and the resistance is given to us that was equal to 450 ohms, and the time is 30 milliseconds. So we just need to simplify this and we will get our final answer. So in this case, final value of energy is equal to 3.8 joules. So this is our final answer. The concept you need to understand from here is that IRMS you need to use when you need to calculate the power or energy dissipated by a resistor.